Okay, so let's go ahead now and take a look at triangles and some of their terminology and whatnot. For starters, a triangle, there's a lot of different definitions out there, but let me just go ahead and give you kind of my idea. First of all, it's a geometric shape, all right? And the second thing is what we call is closed, which essentially means that if any shape that's closed, geometric shape, is kind of like a circle, right? You start somewhere and at some point you come back. Another example would be a rectangle. It's a closed shape. So a triangle, right, there would be my first example of a triangle, right? That's basically a closed shape. So the idea is we can trace it. We start somewhere, make our trace, and then we come back where we're at. So there's actually, even this crazy thing right here, right, that is a closed geometric shape because I was able to start somewhere, trace along the edge, and come back. So there's some math for you. So a closed shape is something that basically has a boundary, right, that encloses some area region, if you would, which is area and perimeter. However, right, so a triangle is a closed geometric shape that consists of three sides, right? And so of the shapes that I have here, right, that would be the triangle because it satisfies the definition. It's composed of three sides, right, and it's closed. This is composed of four sides and it's closed. That's technically has an infinite number of sides and it's closed. And then that one also has some very weird sides to it. But we're talking about a closed shape, geometric shape of three sides. All right, so there's our basic definition of a triangle. It turns out that we could also give our triangles some information with regard to the angles. So let me go ahead and kind of redraw or restructure that triangle over here. One of the geometric facts about a triangle is if I took, let's say, call that angle theta and that angle beta, and how about we call that the angle alpha, right? It turns out that if we added all the angles, right, to any triangle, they will add up to 180 degrees. So that's a very important fact about triangles. So again, they're geometric shapes that are closed, consisting of three sides. Because of the three sides, we now have created three angles, and it turns out that if we summed all those angles together, the sum would equal 180. So pretty important facts as we move forward. Some other facts about triangles is we actually have different triangle types, right? Some triangles are called acute, right? And acute triangles are essentially when we have the angles are all right less than 90 degrees. Recall that an acute angle is an angle that has measurements of less than 90 degrees, and so that's what an acute triangle is, right? All the angles are less than 90. As a matter of fact, I just gave you an example of one up here, right? That's less than 90. That's borderline 90, right? But it's less than it. If I wanted to do something a little more, perhaps something, let me try to do something like this, right? Really come out here. Trying to, right? So there's probably a better acute, right? So this angle is less than 90, that angle is less than 90, that angle is less than 90. So that's what it means to be an acute, all right, triangle. All my angles are less than 90 degrees. Of course, another very famous type of triangle is what we call right, right? A right triangle, basically one angle equals 90 degrees, right? And of course, if one angle equals 90, because of this rule up here, that forces the other two to be acute angles, right? But again, acute triangles, everybody's less than 90. A right triangle, let me draw a real famous one, right? And again, so there'll never be any doubt, what I'll try to do is I'll always try to put a little square there to indicate that that's the angle that is our 90-degree angle. So therefore, that is a right triangle. All right, and then another type of triangle that we have is called obtuse, and this basically means that one of our angles, right, is basically between 90 degrees and 180. So we have one angle that's larger than 90, can't go past 180, right, because again, the sum of all the angles has to be 180, but we're talking obtuse, and these are kind of easier to draw. Here's an example, right, of an obtuse, all right, guy right there. So again, there's would be the obtuse angle, right, dealing with that information. So those are our big types of triangles, right? Some of them are acute, all the angles are less than 90. Most of them are right, and especially in a trig class. But then we also have obtuse, where one angle's larger than 90 degrees. Okay, hopefully my drawings are good, because another way that we can also talk about triangles, another categorization, if you would, is this idea of equilateral. We're going to test my drawings out. An equilateral. Some are also what we call isosceles, and I hope I pronounced that and spelled it right. And then some are called scalene. So there's actually two categories that we can categorize our triangles. Acute, right, and obtuse would be maybe the first round, and then equilateral, isosceles, and scalene. Right, so a scalene, let me start with this one, because this is probably the most common, right? We have here is no sides are equal. So basically there's three sides and none of the sides are equal. So just geometrically looking, right, this would probably be my example of a scalene right triangle. So this is a right triangle that happens to be scalene, because this side is different than this side, which is different than that side. So none of my sides are the same. That's what we mean to be scalene. Isosceles, this basically means that two sides are equal. All right, so that's what that one would be. And I tried really hard to make our obtuse one. This would be my example of an isosceles triangle. It's obtuse because it has an angle that's greater than 90 and less than 180. It's isosceles because those two sides are the same. Of course, geometrically meaning if those two sides are the same, that means those angles are the same, but I'm getting ahead of myself, right? And then that long side's obviously not equal to the other. So that's an example of an isosceles. And then I tried really hard, but looking at my picture, I don't know if I did a good job, all right? But this is where all sides are equal. So if so what I meant to do is draw this guy here. This was supposed to be my example of an equilateral triangle, and perhaps you guys can obviously see I'm not a very good artist. Heck, I don't write very well. So you guys are suffering with my writing, but hopefully you'll be okay. So in this case, all the sides are the same. So I have an equilateral triangle. As a matter of fact, again, just geometrically speaking, that would mean all these angles are the same. 60, 60, and 60. All right, so equilateral triangles, all sides are the same. Isosceles triangles, two sides are the same. And then scalene triangles, nobody's the same. And then, of course, the other category, some are acute, some are right, and some are obtuse. All right, so one more thing I got to say about triangles. We're already 7 minutes into this, so I'll do one more wrap-up of groundwork in another video. See you guys then.